Picture this. While the world was distracted by political headlines and social media drama, China quietly brought back samples from the moon's far side that contained something extraordinary. A Nobel Prize winner, someone who has dedicated their life to understanding our universe, felt compelled to break their usual academic silence to sound an alarm about what those samples mean for humanity's future. This isn't about space exploration anymore. This is about power, resources, and a discovery that could determine which nation controls the next chapter of human civilization. The story begins with one of the most daring space missions in recent history, China's Chang'e 6 lunar probe. After years of planning and billions of dollars in investment, the probe achieved something that no nation had ever attempted successfully before. It landed on the far side of the moon, in the vast South Pole Aitken Basin, a region so remote and mysterious that it had remained almost completely unexplored until now. The South Pole Aitken Basin is no ordinary crater. It is the largest known impact structure on the moon and one of the largest in the entire solar system. Stretching over 2,500 kilometers wide and plunging more than 8 kilometers deep, this basin offers a unique window into the moon's geological history. Because of its depth, scientists believe it exposes material from the moon's lower crust, and perhaps even its mantle, which has been sealed away for billions of years. Landing here meant unlocking secrets buried since the earliest days of our solar system. But landing on the moon's far side is no simple task. Unlike the near side, which constantly faces Earth, the far side is completely hidden from our planet. That means there is no direct line of communication. Every instruction, every transmission, every signal has to be relayed through satellites orbiting the moon. This makes the far side one of the most challenging and dangerous places for robotic exploration. Yet China not only managed to land its probe there, it also succeeded in carrying out a complex series of automated tasks, drilling beneath the surface, collecting samples, and safely sealing them for return. The mission lasted an incredible 53 days. During this time, the probe performed delicate maneuvers with precision that stunned the global space community. Using a new generation of autonomous systems, Chang'e 6 drilled deep into the regolith, the blanket of dust and rock fragments, covering the moon, and extracted material that no human or robot had ever touched before. These weren't just surface samples scorched by solar radiation. These were layers of pristine lunar soil, untouched for billions of years, holding potential clues about the moon's true composition and history. After completing its mission on the lunar surface, Chang'e 6 performed another near-impossible task, launching the sealed sample container back into lunar orbit, where it docked with the return module. This feat alone demonstrates a level of technological maturity that only a handful of space programs in history have ever reached. Finally, after weeks of travel, the capsule carrying the precious cargo re-entered Earth's atmosphere and parachuted safely down, delivering its contents for study. For China, this was more than just a scientific success. It was a statement to the world, proof that their space program has evolved into one of the most capable and ambitious on the planet. While the United States, Russia, and other nations have explored the moon in the past, no one had ever achieved what Chang'e 6 did, a fully robotic mission to the far side, a place once thought impossible to reach, with a successful return of samples. The implications of this achievement cannot be overstated. It marks the beginning of a new chapter in lunar exploration, one where China is no longer just a participant, but a leader. And what those samples revealed upon their return to Earth would send shock waves through the scientific and geopolitical world alike. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. When the Chang'e 6 capsule finally touched down on Earth, scientists wasted no time rushing the precious lunar cargo into carefully controlled laboratories. Inside were fragments of dust, soil, and rock collected from the far side of the moon, material that no human eye had ever seen before. The moment researchers opened those sealed containers, the world of planetary science changed forever. Early examinations immediately revealed something astonishing. The samples contained traces of water ice embedded within the lunar regolith. For decades, astronomers had speculated about frozen water lurking in permanently shadowed craters near the moon's poles. But direct physical evidence had remained elusive. Now, with the material in hand, there was no longer any doubt. Water, the most vital resource for life, for breathable oxygen, and even for rocket fuel, was present on the far side of the moon. But the surprises didn't stop there. As researchers dug deeper into their analysis, they uncovered another revelation: the presence of helium-3, an isotope almost non-existent on Earth. For scientists and futurists, helium-3 has long been considered a potential game-changer. It is one of the most promising fuels for nuclear fusion, a form of energy that could theoretically provide humanity with limitless, clean, and nearly waste-free power. On Earth, only a few kilograms of helium-3 exist naturally. On the Moon, however, billions of tons may be embedded in its soil, deposited by billions of years of solar winds. And now, thanks to Chang'e 6, we know with certainty that this rare isotope is not just a theory. It's a reality waiting to be harnessed. Then came perhaps the most mysterious discovery of all. Some of the samples showed unusual silicate and metallic oxides with crystalline structures that had never been documented before. Their exact composition remains closely guarded, but leaked reports suggest these materials may have unique electrical and thermal properties. In other words, they could one day form the backbone of next-generation electronics, advanced superconductors, or even military technologies that today sound like science fiction. Think about what this means. In one mission, China uncovered 3 resources that could reshape the future of humanity. Water, the foundation of life and exploration. Helium-3, the potential key to solving the world's energy crisis. And exotic new materials capable of transforming industries from computing to defense. Each one of these findings alone would have been historic. Together, they paint a picture of the moon not as a barren wasteland, but as a treasure chest of unimaginable value. The implications go beyond science. Whoever controls access to these resources could control the future of energy, technology, and even space travel itself. And for the first time in history, it is China, not the United States, that is holding the samples and setting the pace. These discoveries are more than just scientific footnotes. They are the spark that could ignite a new space race, one unlike any the world has ever seen. For decades, scientists have dreamed of a future powered by nuclear fusion, the same process that fuels the stars. Unlike traditional nuclear fission, which splits atoms apart and creates dangerous waste, fusion combines light elements like hydrogen into heavier ones, releasing enormous amounts of energy with almost no radioactive byproducts. It is the holy grail of clean energy: limitless power, no greenhouse gases, and virtually no long-term waste. But there has always been one challenge: finding the perfect fuel. Here on Earth, the fuels we've experimented with, such as deuterium and tritium, have limitations. Tritium is radioactive, dangerous to handle, and produces neutrons that can make reactor walls brittle over time. That's where helium-3 comes in. This rare isotope of helium is non-radioactive, produces very little waste, and in theory, could power a fusion reaction that is safer and far more efficient. In fact, just 25 tons of helium-3 could provide enough energy to power the entire United States for a year. The problem? Earth barely has any. Our planet is shielded by a magnetic field that blocks the solar wind, preventing helium-3 from ever accumulating here. But the moon is different. For billions of years, its surface has been bombarded by the solar wind, embedding helium-3 deep into its regolith. Scientists have long suspected that the moon, especially its far side, might hold vast quantities of this fuel. And now, thanks to Chang'e 6, we finally have confirmation. China's samples showed concentrations of helium-3 that were not only present, but higher than anyone expected. This discovery is a turning point. It transforms helium-3 from a theoretical dream into a tangible resource, one that could one day be mined, refined, and brought back to Earth to revolutionize how humanity powers its cities, industries, and technologies. Imagine a future where oil and gas wars are relics of the past, where coal plants stand abandoned, and where humanity taps into a virtually inexhaustible energy supply from space. Entire economies would be reshaped. The balance of global power could shift overnight. Countries that gain access to lunar helium-3 would hold the keys to the world's energy future. Of course, there are still hurdles. Fusion reactors capable of efficiently burning helium-3 are not ready yet. Scientists are making progress in laboratories across the world, but commercial fusion power has always been called just 20 years away, and yet the existence of accessible helium-3 may change everything. Knowing that such a resource is real and obtainable could accelerate research, funding, and innovation, pushing fusion technology toward maturity faster than anyone predicted. And here lies the geopolitical weight of China's discovery. By securing physical proof of helium-3 on the far side of the moon, China isn't just advancing science, it is positioning itself at the forefront of what could become the most valuable energy race in history. The nation that first manages to extract, transport, and harness helium-3 won't just lead in space exploration. They could dominate the global energy economy for centuries to come. If helium-3 represents the promise of limitless energy for Earth, then water ice represents the foundation of survival and expansion in space. Hidden in the shadows of lunar craters, protected from sunlight for billions of years, frozen water has been one of the moon's greatest mysteries. For decades, scientists debated whether it was really there or just an illusion from orbital scans. Now, Chang'e 6's discoveries have made it undeniable. The moon does indeed hold ice, and that changes everything. Why is this so important? Because water is more than just something astronauts drink. With the right technology, it can be broken down into oxygen and hydrogen through a process called electrolysis. Oxygen, of course, is breathable air, the very thing humans need to survive on another world. Hydrogen, on the other hand, is a powerful rocket fuel. Combine the two, and you have liquid oxygen and liquid hydrogen, the same propellant mix that powers some of the most powerful rockets ever built. This means the moon is not just a destination, it is a refueling station. Imagine a future where spacecraft no longer need to carry all the fuel they'll ever need from Earth. Instead, they could launch with lighter payloads, travel to the moon, refuel at a lunar depot, and then continue deeper into the solar system. Missions to Mars, Jupiter, and beyond would suddenly become cheaper, safer, and more practical. The moon would become a gateway to the stars, a cosmic pit stop for humanity's expansion. But the strategic value goes even further. Establishing lunar supply hubs could open the door to commercial spaceflight on an entirely new level. Private companies could operate fuel stations, resupply services, and even sell oxygen for life support. Nations could establish bases not just for science, but for trade, exploration, and eventually colonization. What today sounds like a scene from science fiction. Bustling lunar outposts, fuel tankers moving between Earth orbit and the moon, humans preparing for journeys far beyond, is suddenly starting to look like a very real possibility. And here's where the geopolitical significance comes in. Whoever controls the moon's water ice will control access to the rest of the solar system. Think about that for a moment. It's not just about survival on the lunar surface. It's about building the infrastructure of space civilization. A permanent Chinese lunar base with its own fuel production and supply chain would give Beijing unprecedented leverage. Any nation or company wanting to explore beyond Earth might one day need to rely on Chinese-controlled resources. This is why the discoveries of Chang'e 6 have rattled the world. The moon is no longer a barren rock. It is a staging ground, a supply hub, and a potential launch pad for human destiny. With every scoop of lunar soil that China brings back, the dream of turning the moon into humanity's gateway to the solar system comes closer to reality. When we think about great leaps in human space exploration, we often picture astronauts in bulky suits, planting flags or building habitats with their own hands. But China's Chang'e 6 mission has revealed something different, a future where much of the heavy lifting on the moon may be done without humans at all. This mission wasn't just about collecting lunar soil. It was a bold demonstration of AI-driven autonomy, robotic precision, and advanced sample return engineering, technologies that push China far ahead of most competitors. The lander itself is a marvel. Once it touched down on the rugged, unexplored, far side of the moon, it had to make decisions on its own. Unlike missions on the near side, there was no direct line of communication with Earth. Every command had to pass through a relay satellite. That delay meant the lander's systems had to be capable of real-time thinking. Using artificial intelligence, the probe could assess terrain, identify safe landing zones, and adapt its drilling strategy to ensure the most valuable samples were taken. In other words, this wasn't just a remote-controlled robot. It was a self-reliant explorer. Then came the challenge of drilling. The lunar regolith is unpredictable, with layers of dust, rock fragments, and hardened crust. Yet Chang'e 6 deployed, its robotic arm and drill with surgical precision, boring into the surface to extract material not just from the top layer, but from beneath, soil and rock untouched for billions of years. That alone is groundbreaking, but what followed may be even more impressive: real-time analysis and targeting. The lander's systems could evaluate samples as they were being collected, prioritizing which material should be returned to Earth, and ensuring nothing was wasted. The return process was no less extraordinary. For the first time in history, samples from the far side of the moon were launched into lunar orbit, rendezvoused with an orbiter, and then safely transported back to Earth. Every stage of this operation demanded perfect timing, navigation, and engineering precision, and China executed it flawlessly. It was a moment that signaled to the world China has mastered not only landing on the moon, but also bringing its treasures home. And here's the deeper implication. If China can automate landings, drilling, analysis, and sample returns, then what comes next is clear: semi-autonomous lunar bases. Imagine robotic fleets that can build habitats, mine ice, extract helium-3, and construct power stations long before a single astronaut sets foot on the site. By the time human crews arrive, much of the infrastructure could already be waiting, assembled by machines that work tirelessly without food, water, or rest. This is more than science fiction. It's a roadmap. Autonomous robotics would allow China to operate at a scale impossible for manned missions alone. Hundreds of tons of regolith could be processed. Mining operations could run around the clock. Lunar bases could expand year after year, all while minimizing the risks and costs of sending human crews into deep space. In short, China is laying the groundwork for industrial-scale operations on the moon. And perhaps most important of all, these advancements position China to lead not just in exploration, but in control of lunar infrastructure, a country that can set up automated supply hubs, power systems, and resource facilities first will hold a commanding advantage. Others who follow may find themselves dependent on what China has already built. So when we look at the Chang'e 6 mission, it's not just a scientific milestone. It is proof that China is engineering the future of lunar dominance, a future where machines pave the way and humanity follows. Every great discovery in human history has come with a question: who controls it? The moon is no exception. While Chang'e 6 has thrilled the scientific world, it has also opened a Pandora's box of legal and geopolitical challenges. At the heart of this debate is a decades-old agreement known as the Outer Space Treaty of 1967. Signed at the height of the Cold War, it was meant to prevent the moon and other celestial bodies from becoming battlegrounds or colonies of individual nations. The treaty clearly states, no country can claim sovereignty over the moon. But here's the catch. The treaty was written in an era when humanity had barely set foot on the lunar surface. No one imagined industrial-scale mining, automated resource extraction, or permanent lunar outposts. The document bans ownership of land, but it does not explicitly forbid resource extraction. And that loophole changes everything. If no one owns the moon, does that mean no one can own the ice, the helium-3, or the minerals taken from it? Or does it mean whoever extracts them first has the right to use and profit from them? This gray area has created a dangerous vacuum in the international law, and China, through its Chang'e missions, may be on the verge of exploiting it. By physically collecting and transporting lunar material back to Earth, China is not just doing science, it is setting precedent. The first nation to establish regular extraction and use of lunar resources could claim a kind of de facto ownership, not through law, but through action. Once a supply chain is in place, and once a nation has built infrastructure around those resources, it becomes nearly impossible for others to challenge their control without conflict. This is why governments around the world are watching closely. The United States and its allies have introduced the Artemis Accords, a set of voluntary agreements that aim to govern lunar exploration and ensure transparency, cooperation, and peaceful use. More than 30 countries have signed on, but China and Russia have not. Instead, Beijing has been pushing its own vision of lunar governance, often aligning with nations outside the US-led framework. What we're seeing is not just a scientific rivalry, but the emergence of competing legal systems for space. The stakes are enormous. If China succeeds in building the first fully operational lunar base, powered by extracted water and helium-3, it could dictate the terms of future lunar activity. Access to fuel depots, landing zones, and mining regions could become restricted. Other nations might find themselves dependent on Chinese infrastructure, forced to pay for access to the very resources that are supposed to belong to all of humanity. And here lies the irony. The Outer Space Treaty was designed to prevent the moon from becoming a new frontier of competition. Yet by leaving the rules of resource extraction undefined, it may have sparked the very race for dominance it sought to avoid. Unless the international community reaches a new consensus, fast, the legal vacuum could escalate into open disputes, both on Earth and one day on the lunar surface itself. In this sense, Chang'e 6 has not only rewritten science textbooks, it may be rewriting the rules of space law itself. And the longer the world hesitates to agree on those rules, the more likely it becomes that China, through bold action, will define them for everyone. For decades, the original space race between the United States and the Soviet Union was seen as one of the defining struggles of the 20th century. But now, more than half a century after Apollo, a new space race is unfolding. And this time, the finish line is not simply planting a flag, but owning the future of the moon. The Chang'e 6 mission has dramatically raised the stakes. By bringing back never-before-seen samples from the far side of the moon, China has shown not only its technological strength, but also its long-term vision to dominate lunar exploration and resource utilization. The West has taken notice. NASA, the European Space Agency, and their partners suddenly find themselves under immense pressure to accelerate their own program, especially the Artemis missions, which aim to return astronauts to the moon by the end of the decade. But here's the challenge. While the US model relies on a mix of public funding and private enterprise, China's space program is state-driven, centrally planned, and backed by billions in guaranteed funding. There are no delays caused by shifting political priorities, no dependence on private companies meeting deadlines. Instead, Beijing has crafted a focused, long-term strategy, one that spans decades, not election cycles. This singular vision allows China to move with speed and efficiency that Western nations often struggle to match. For the United States and its allies, the risk is not only falling behind scientifically, but losing control over the infrastructure of space itself. Artemis is designed to place astronauts on the lunar South Pole, where vast reserves of water ice are believed to exist. But every delay, every funding shortfall, every technical setback widens the gap with China. If Beijing establishes permanent outposts first, it will gain both the resources and the geopolitical leverage that come with them. The rivalry is not confined to government programs either. Private companies like SpaceX, Blue Origin, and others are playing pivotal roles in the Western strategy, developing new rockets, landers, and supply systems. Their innovation and competition bring incredible potential, but also uncertainty. Timelines slip, projects overrun budgets, and political debates in Washington can halt progress overnight. China, in contrast, does not face these same obstacles. Its centralized model allows for relentless progress, regardless of cost. What is emerging is a two-speed race for lunar dominance. On one side, a coalition of democracies driven by innovation, cooperation, and commercial ambition, but vulnerable to delays. On the other, a single nation with a tightly controlled, heavily funded long-term agenda. And for now, China appears to be pulling ahead. This is not just about science. Whoever controls the moon's water, its helium-3, and its strategic landing sites will control humanity's gateway to the solar system. The space race of the 20th century was about prestige. The space race of the 21st century is about power, resources, and survival in a new age of exploration. For centuries, humanity has looked up at the moon and seen a silent, barren world. But if China's vision plays out, the moon may soon transform into something far more ambitious. The first industrial hub beyond Earth. The lunar surface offers unique conditions for manufacturing that simply do not exist on our planet. Its low gravity, near-vacuum environment, and absence of biological contaminants create the perfect setting for producing materials of extraordinary purity. Processes that are disrupted by Earth's atmosphere, from crystal growth to metallurgy, could take place on the moon with unprecedented precision. Imagine fiber optics with no imperfections, microchips manufactured at atomic-level clarity, and high-purity metals forged without trace impurities. These aren't science fiction concepts. They are real technological possibilities that could redefine entire industries. China's plans extend beyond mere resource extraction. The long-term strategy is to build a closed-loop supply chain in space. It starts with mining helium-3 and water ice, two of the most valuable lunar resources. The helium-3, harvested from the regolith, would one day power fusion reactors capable of delivering clean, limitless energy. The water ice, split into hydrogen and oxygen, would fuel spacecraft and sustain life for crews. But the vision doesn't end there. Instead of hauling raw materials back to Earth, China could use them directly on the moon to manufacture satellites, structural components, and even replacement parts for spacecraft. In this model, the moon becomes both the factory floor and the gas station of the solar system. Rockets could be launched from its surface at a fraction of the cost required on Earth, bypassing the expensive drag of Earth's gravity well. Satellites could be assembled in orbit, powered by lunar resources, without a single Earth-based launch. If achieved, this would represent a revolution in space economics. Today, every mission depends on launching everything from Earth: fuel, hardware, and life support systems. But in a future where the moon produces its own fuel, its own materials, and its own technology, Earth launches could become secondary. The cost of accessing space would plummet, and whoever controls that lunar industrial chain would control the backbone of the entire space economy. China has already hinted at this ambition. Its long-term proposals involve robotic construction systems, solar power farms spread across the lunar surface, and even 3D printed habitats for sustaining human or robotic crews. Step by step, each mission brings it closer to that reality. And while the world debates laws and politics, Beijing is building the foundations of what could one day be the first extraterrestrial civilization, an industrial colony on the moon. This isn't just about exploration anymore. It's about transforming the moon from a celestial neighbor into a working outpost, a hub of energy, technology, and power. And if China succeeds in industrializing the moon before anyone else, it won't just lead the new space race. It will own the future of space itself. While the moon has long been seen as a place for science and exploration, China's advances with Chang'e 6 and its broader lunar program raise profound questions about security and military strategy. A permanent lunar base is not just a scientific outpost, it is a strategic asset with dual-use potential. During peacetime, it supports research, resource extraction, and technological development. But in a crisis or conflict scenario, that same infrastructure could serve intelligence, surveillance, and even defensive purposes. One of the moon's unique advantages lies in its geography. The far side of the moon is permanently shielded from Earth's radio signals, creating a zone of near-complete radio silence. For scientists, this is ideal for astronomy and space research, enabling telescopes to observe the universe without interference. But for military applications, the same property is a gold mine. It allows for the development of secure communication systems, quantum networks, and highly sensitive monitoring stations that cannot be jammed or spied upon from Earth. Imagine a lunar base equipped with high-resolution surveillance instruments capable of monitoring satellites, space traffic, or even Earth-based targets with unprecedented precision. Combined with satellite constellations in Earth orbit, this capability could give China strategic advantages in both defense and intelligence. The moon could essentially become a command and control hub beyond the reach of any terrestrial adversary. The dual-use nature of lunar infrastructure makes international oversight incredibly complicated. While the Outer Space Treaty forbids weapons of mass destruction in space, it does not ban surveillance installations, communications arrays, or dual-purpose research facilities. China's investments in autonomous robotic systems, energy harvesting, and fuel production further enhance the strategic potential of a permanent outpost. Once these systems are operational, any future lunar expansion by other nations would be heavily influenced by China's existing presence. Moreover, the ability to extract helium-3 and water ice doesn't just provide energy. It could support long-duration crewed missions, deep space refueling, and satellite maintenance, giving China a permanent logistical advantage over other spacefaring nations. In a future where lunar control equates to space dominance, the first nation to secure resources, infrastructure, and technology could define the rules for all others. Ultimately, the moon is no longer a neutral scientific frontier. It is fast, becoming a geostrategic platform where technology, resources, and surveillance converge. China's advances signal that whoever controls the moon first could gain not just scientific prestige, but military and strategic leverage that shapes the future of both space and Earth-based geopolitics. For centuries, the moon was humanity's silent companion, a barren rock, a distant muse for poets, scientists, and dreamers. But now, thanks to China's Chang'e 6 mission and the revolutionary discoveries it has returned, the moon is no longer a passive observer. It is fast becoming a strategic foundation for humanity's future, a platform that could support energy, industry, and deep space expansion on a scale never before imagined. The helium-3 found in lunar soil could unlock clean, near-limitless energy, potentially reshaping the global energy landscape. Water ice, harvested from shadowed craters, could supply fuel and oxygen for humans and spacecraft alike. Together, these resources transform the moon from a barren satellite into a launch pad for human civilization, enabling permanent outposts, refueling stations, and industrial hubs that function independently of Earth. This is no longer science fiction. It is a tangible, rapidly approaching reality. Control of these resources carries profound geopolitical implications. The first nation to secure large-scale lunar infrastructure could influence the future of global energy markets, dominate space logistics, and establish strategic leverage over other nations' space programs. Lunar power could translate directly into earthly power. Nations left behind could face a world where access to space, energy, and advanced technology depends on those who control the moon's bounty. But the consequences go even further. Lunar industrialization could spark the birth of a new space economy, producing high-purity materials, microchips, and energy in ways impossible on Earth. Entire supply chains could operate off-world, reducing the cost of exploration and colonization across the solar system. Human settlements on Mars, asteroid mining operations, and deep space satellites could all be supplied from a moon-based infrastructure, fundamentally altering the economics of space travel and commerce. The moon's strategic value is not purely economic. It is also a geopolitical chessboard where energy, technology, and military capabilities intersect. Whoever establishes a permanent presence first, controlling resources, industrial capacity, and infrastructure, will set the rules for how humanity expands into space. International treaties, political negotiations, and technological advancements will be shaped by this new reality, making the moon the most contested frontier of the 21st century. In short, the moon has awakened. It is no longer just a celestial neighbor or a scientific curiosity. It is a civilization-scale opportunity, a platform on which the next era of human development will be built. From energy independence and industrialization to strategic advantage and deep space exploration, the future of humanity may very well pivot on who controls the moon first. Chang'e 6 has not only revealed new science, it has unveiled a vision of our collective destiny in the cosmos, and the race to claim it has only just begun. From the first footprints of Chang'e 6 to the promise of lunar industry, helium-3 energy, and permanent outposts, the moon is no longer just a distant world. It has become a strategic, technological, and economic frontier that could define the next century of human civilization. China's breakthroughs have shown us that the moon holds more than rocks and dust. It contains the building blocks for energy independence, industrial revolution, and even deep space colonization. Whoever controls these resources first will not just shape the future of space exploration, but potentially the future of life on Earth itself. The race for the moon is no longer a story of exploration alone. It is a story of power, ambition, and the next great leap for humanity. From scientific discovery to industrial might, from energy to security, the moon has awakened, and the world must now reckon with the opportunities and challenges it presents. As we look up at the night sky, the question is no longer whether humanity will return to the moon, but who will shape its destiny first, and how it will change all of us in the process. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.